Hello everyone, welcome to this demo that will be about centralizing knowledge about packages that should be shipped. This is, I would say, a natural consequence of a proposal to ROTS container image builds. And let's get started. So the idea here is to centralize or create a central place where people can declare supported or verified or working packages that can be used in container images. So basically have a list of Python packages that are known to be working in supported environments. It can be some deployment of an application that requires certain version of packages. So, for example, Ray container images. And in that case, people can state these supported packages in one place, and then let resolve software packages that satisfy this requirement. This requirement on packages, package versions, but also source of packages can be stated at one place and can be on direct dependencies. So if there's an array container image, then dependency on array itself, but also on transitive dependencies of array or any other Python package. Then this centralized logic or centralized place can be used to resolve software stacks considering this knowledge. So if we take a look at it in a high-level overview, we have a build system that asks which packages should be included or should be installed during the container image build process. This question goes to Todd that uses the aggregated knowledge about Python packages, and also this list of Python packages that should be shipped in that specific build process. So Todd resolves software stacks and suggests which packages should be installed into container images that are built. The implementation of this uses a feature that is called labeled request to Todd or to the cloud-based resolver, and this implementation uses a feature that is called prescriptions, which is basically a database that is easy to extend, as it is written in the YAML file, and easy to maintain for people that would like to use it. Then, if this database is labeled correspondingly, any request to the resolver that is labeled with a specified label then considers prescriptions that should be applied to the resolution process. Okay, so let's have a look at example. This example is in a pull request that is to prescriptions repository, and it adds versions of Python modules that are specific for container images that are built by AICOE CI for ROTS. The example is pretty straightforward. So there are different type of pipeline units that can be plugged into the resolution process, and they have different semantics. So follow online documentation to see how these pipeline units can be used and how they can be structured. Very briefly, we can take a look at some example. So let's say we will take Jupyter Hub as an example. Here we have a pipeline unit that is specific for Jupyter Hub. That means if Jupyter Hub is in a software stack, then this pipeline unit is applied, but also, as stated before, the request to the resolver needs to be labeled. In this case, it needs to be labeled using label consumer rods. What happens in that case? In that case, this pipeline unit is registered in the resolution process, and the actual logic of this pipeline unit is that if there is a Jupyter Hub, or if there is a possibility to resolve Jupyter Hub on the server-side resolver, then always consider version 0.3.0. Then there is also printed informative message or warning message to the resolution log, and also a link to data science, OpenShift data science article. That means that any stack that would use Jupyter Hub, either directly or indirectly, would always resolve to Jupyter Hub in version 1.3.0. If the resolution does not meet this or cannot satisfy version range requirements of other dependencies, then the resolution process will fail. But here we can see that we have centralized logic where we say everything that is built for rods should include Jupyter Hub in version 1.3.0, as that is known to be working in rods deployment. Similarly, you can see similar requirement on, for example, Bokeh. So if there's other Bokeh than 2.3.0, then it is removed from the software stack. You can use any version specification known in Python ecosystem, so you can do above certain version, below certain version, or you can point to a specific Python package index that you would like to use, and all these features. Okay, so that would be it. If you are interested in this feature, feel free to visit ToadStation prescriptions repository. Also, feel free to browse documentation on labeled requests. But basically, build pipeline should provide just one environment variable that specifies the label that should be used during the resolution process and triggers inclusion of certain pipeline units in the resolution. And you can also check YouTube video about labeled requests to the resolver that can give you more insights about how to configure the build pipeline or any client tool that consumes Toad's recommendations. This way, I would like to thank you and see you next time.